Hello, this is Mrs. Booth again, and in this video we're going to talk about the properties of a quadratic, specifically the properties on a graph. So the graph is super easy. All we got to do is look with our pretty little eyes and find the information. So I put major dots, big old dots, on things that are pieces of information that are properties of our quadratic. But the first thing that we can figure out just by looking at it is which direction our parabola is opening. So is my parabola opening up or is it opening down? Yeah, really easy. It's opening down. Okay, that's going to tell me some information about my quadratic. And if I remember from my transformations, that tells me that it's reflected. So I'm going to put a little note over here for transformations that I know that this graph is reflected. Okay, super easy. All right, so now let's look at all those big, beautiful dots. So I noticed this big dot at the top. So what do we call that? It has a special name. You can call it 3 different terms. In this case, only 2 of them apply. The first one is, this is our vertex, right? It's a starting point or a vertex. And this one's also a maximum. How do we know it's a maximum? Yeah, it's at the top of the hill. So it's the highest point. It's at the very tippy top of the hill. Then it's a maximum. So if my parabola opened down, it would be at the very bottom of a valley. And at the very bottom, that's my minimum. Okay, so for my vertex, let's find the location of my vertex. And I'm just going to abbreviate that with a V. Right, my vertex is at -2, 9. So I not only know the parabola has a vertex, I know exactly where that vertex is located on my graph. Okay, so now let's look at these other dots. Notice all of these other dots are intersection points. So this dot is where it intersects with the, very good, y-axis. So that makes it a y-intercept. Okay, so every parabola has a y-intercept. It may not show up on your calculator because it's not between 10 and 10, right? But everything has a y-intercept. And where is this y-intercept? 1, 2, 3, 4, 5. So is that 0, 5 or 5, 0? Yes, it's 0, 5, right? Remember the 5 is on the y-axis, so the 5 goes in the y position. Okay. So now let's look at those last 2 dots. Notice these last 2 dots are where it crosses the x-axis, very good. And there's several different names for these. So these are x-intercepts. They're also called roots or solutions, okay? So in Algebra 2, we're going to refer to them a lot as roots. And notice I have 2 different x-intercepts because my parabola is U-shaped. It's going to intersect twice. So my first one over here on the right-hand side, very good, is at 1, 0. And the second one over here is at -5, 0. Now you may think, you're done, right? We're done. Okay, there's one more piece of information. One of the beautiful properties of a parabola is that it's completely symmetric. Everything over here on the left is going to line up or match up with everything on the right if I were to fold it right in half. So if I just take left and right side and fold it together, it's going to match up right down the middle. So that line that cuts it in half, that line is called the axis of symmetry. Okay? Think of it as a little imaginary dashed line. Okay, and this is my axis of symmetry. I'm going to abbreviate it. We call it the AOS for axis of symmetry, right? And where is that located? Well, it should go through the vertex because the vertex is right in the middle, okay? And the x value from the vertex should always be where my axis of symmetry is at. So I have x equals -2. Now some of you say, well, why is it x equals and not y equals? Well, it's really easy. Whatever axis it's cutting across, So this vertical line crosses the x-axis at -2. So it's x equals -2. If it was y equals, it would be a horizontal line. It would be going this way. Okay, so we have a vertical line. So we have two different ways. There's actually three ways, three forms that the quadratic equation or the quadratic function can be written. And we can find two of them directly from the graph. Okay? The first one is the factored form. So factored form. Factors are the same thing as roots or solutions or x-intercepts. So our factored form, and you're going to assume that a equals 1 for all of these. We're going to assume a equals 1. If I give you a graph, it's going to be a equals +1 or -1. So is this one +1 or -1? Very good. It's negative. How do I know it's negative? Oh, yeah. It's reflected. It's pointing down. Got to remember those transformations. So, my factored form, I have the a out front, and then it's x minus one of my roots, and x minus the other root. It doesn't matter which order you go in. Okay? So let's see what we're going to get. Okay? So we got y equals, what was my a value? Yeah, we said it's -1. So we can put a -1 or we can just put a negative sign. Either way. Okay? And then I need to list my two roots. So I'm going to put my x's up front. So I look over at my roots. My roots were at +1, but I'm subtracting. So positive, when you change the sign, becomes, very good, negative. So I'm going to put -1. And that means my -5 would become, very good, +5. Okay, so the factored form for this quadratic graph, or quadratic function, is y equals -x minus 1 times x plus 5. Okay, easy. All right, so now let's look a little bit more at our transformations. So the key to finding your transformations is to start at 0, 0, and you're pretending like you're giving directions. You ever give directions to somebody? Hopefully you do a better job than Siri, right? So I want to go to my vertex. I'm starting at 0, 0. To get to my vertex, which way do I go? Do I go to the right or do I go to the left? Yes, I go to the left. So one of my transformations is that I'm going to the left. How many am I going to the left? 2. Okay? So I'm going to write that up here. Left 2. I apologize for the abbreviation. I'm running out of room. Okay? I not only have to go left 2, but remember, I still got to get to my vertex, and the vertex is up here. So I go left 2, and then I go up how many? 9. This is where my vertex is. Okay, well this makes sense. Then we're going to go up 9. So I go left 2 and up 9. -2, +9. Okay, we're getting this. All right, so now we're going to use those transformations. Think back to transformations. That's what your vertex form is in, because it uses the vertex, which is how we get our transformations. So the vertex form, you know it. A, parentheses, x minus h squared, and then plus k. All right, super easy. Same thing. So I got a, my y equals, what was my a? Yep, -1. Okay, and now I need my x with something squared. Okay, so what are we going to put inside the parentheses? So we moved left 2. So is to the left positive or negative? Very good. Left is positive. Remember, it's the spy on the inside that lies to you. So my left is positive. And then we're going up 9. Yes. So I got to put a +9 at the end where my k value would be. And now I have all of the properties for my quadratic graph. And I have the quadratic equation written 2 different ways. We'll talk about how to write it in standard form in another video.